there's one more twist in the subtraction tale, and that is subtracting from whole numbers. Let's think about addition first. So look at this. So if I have 5 plus a half, that's pretty easy, 5 and a half. Or if I have 5 plus 3 and a half, I'm going to add the whole numbers. 5 plus 3 is 8, and nothing plus a half is a half, so 8 and a half. But what about the subtraction? So this is where it gets a bit complicated once again. Subtraction tends to be a bit of a spoiler. So let's have a look at one. So what about 5 minus a half? Now, you probably know in your head that that's going to be 4 and a half. But what's the process whereby you get that? Because I could give you 32 minus 6 and 3/7, and then it becomes a little bit more complicated. So these ones you can of course do in your head, but it does get a little more complicated later. So let's go into a process, but we will start with 5 minus a half because you know that 4 and a half is going to be your answer. So whatever process we use, that's going to be our target. So it comes down to this 5. We've got to somehow think of this 5 as a fraction. I want you to think about the number 5 as an answer to a division. So think of a division question where something divided by something gives you 5. So you might think, well, 25 divided by 5 gives me 5. And that would be fine. You would end up with this, rewriting that as a fraction. Remember the relationship between the division and fractions. 25 over 5. Well, you could actually do that as your subtraction from the whole number. But there's an easier way. You've got to try and get this down to the lowest possible value. So now let's rethink our original question. What's the smallest combination of things you can put into these boxes that gives you the answer of 5? Well, I'm hoping that you came up with the idea that it is in fact 5 divided by 1. 5 divided by 1 equals 5. And if I write that as a fraction, this is 5 over 1. And that is the key to doing these subtractions from a whole number. A whole number expressed as a fraction is itself over 1, because that's the easiest division you can do to create that same number, that same whole number. All right, so now let's use that notion to reconceive our original question. All right, so I'm going to leave that there, but I'm going to underneath rewrite that question. So it's 5 over 1 minus 1 over 2. So now we've got a subtraction with different denominators. Now, if you remember what we need to do, we need to come up with a common denominator. That is, we need to come up with a denominator that works for both. Now, the method we talked about before, we talked about multiplication. 1 times 2 is 2, so our denominator can be 2. And now we think, how did we get there? So 1 times what gives me 2, 1 times 2 gives me 2, so the top gets multiplied by 2 as well. 5 times 2 is 10 minus, and now we do the other part, 2 times what gives me 2, well 2 times 1, multiply the top by 1, 1 times 1 is 1, and of course this number stays the same because this is the denominator that we have chosen. Alright, so now we can do the subtraction. 10 minus 1, what is 10 minus 1? 10 minus 1 is 9 over what? The denominator stays the same, 9 over 2. Now we still haven't got this. Do you know why? Because we haven't converted it back into a mixed number. So we'll do that now. So remember what 9 over 2 is. It's like saying 9 divided by 2. How many 2's go into 9? Well, 2, 4, 6, 8. So that's 4. And I got to the number 8, but I need to get to the number 9. So there's 1 left over. And I write that as a fraction over the denominator, which stays the same. So it becomes 4.5. So that's our process. So you can see the logic behind it. Now that we've dealt with that one, let's do another one where it's not as obvious what the answer is when you do it. So let's do 12 minus 3/7. Okay, if you've got a really good knowledge of that 3/7, if you can really picture it, you can probably get to the point where this is easy enough to do in your head. But I'm going to go the long way. But if you're doing it in your head, you're thinking, what's the difference between 3/7 and a whole? And that kind of is the answer, but let's go the long way. So this can be written as 12 over 1 minus 3/7. So we need to come up with our new denominator. Okay, so 1 goes into 7, so 7 is going to be our denominator. How did we get there? Well, 1 times what gives me 7? It's 7, of course. And then 12 times 7, you need to know your 12 times table, or you need to look up your 12 times table. I'm just going to count it out. 12, 24, 36, 48, 60, 72, 84. So 84 is the number. Minus, well, this is the denominator. Okay, that's the one we've chosen. So that hasn't changed. So this hasn't changed. So it's going to be 84 minus 3. So 84 minus 3 is 81 over 7. And you remember that this is kind of like a division question. It's 7 into 81. How many 7s go into 81? So we can just do it as a straight division. 7 into 8 goes once, with 1 left over. 7 into 11 also goes once. And what is the leftovers? Well, 7 plus 4 is 11. So 4 is left over. And we express the remainder over this number here. So it's 11 and 4 over 7. So that's our final answer, 11 and 4/7. So with a good knowledge of division and understanding that when you have a whole number, you can express it as a fraction, which is just simply over 1, you can then do subtractions from whole numbers quite easily. The other way to do it, and maybe you're kind of seeing this a little bit, look, you've got 3/7. How do I kind of make that a whole number? Well, 3 plus 4. Okay, 3 plus 4 gives me 7 over 7, which is that whole number. So 12 minus 3/7, it's the next number down, which is 11, and the difference, which is 4 over 7. So that's a way you can do it in your head. Either way works. Once you've done a lot of these, you'll discover all sorts of tricks and shortcuts. It just takes too long to explain them all. This isn't all of them. There's a thing called, you can do cross multiplication and all sorts of things like that. It's more of a classroom thing. I can't possibly go through every iteration. Well, I can, but I'd be making an epic video, almost like a Netflix 10-part series. But for the time being, you can just use this method, and feel free to Google other videos which tell you other shortcut methods. So there should be some subtractions from whole numbers attached to this video, or possibly on another worksheet, and you can have a go at doing that. You shouldn't have a problem. At a certain point, you'll be able to do them in your head almost. But of course, as ever, if you have any issues, let us know.